let's jump right in and look at a sequence, okay? And then we'll talk about format and notation and what makes a sequence, okay? So first example here, example 1, we're going to list the first 5 terms of a sequence defined explicitly this way. I'll talk about explicit also in a minute. First things first, we're going to have the term. So when we are on the first term, we're going to say n is a 1. When we are on the second term, n is a 2. Third, fourth, fifth. Okay, so looking at this formula, when n is a 1, we will have a -3 plus 8. When n is a 2, we will have a -6 plus 8. When n is a 3, -9 plus 8. I'm plugging in right here into the n spot. When n is a 4, we'll have -12 plus 8. When n is a 5, -15 plus 8, which means the first term is a 5, the second term is a 2, third term is a -1, fourth term is a -4, and fifth term is a -7. So the first 5 terms, 5, 2, -1, -4, -7, and we could keep this going, okay? Now, this is a sequence. Why? Well, it's a series of numbers, a series of terms, okay? Next, it is it's an explicit formula, and here is why. When we are working with the formula, the number that we plug in for n is the term that we're talking about. So when I plugged in a 1, I was talking about the first term, okay? That is an explicit formula, okay? All right, I'll come up here, talk about a couple things. Here, they're generically saying a sub n, and when we write a sub 1, that is when 1 is plugged into the n spot and we're on the first term. When we plug a 2 in the n spot, we are on the second term, okay? So on and so forth. So nth is the term. Explicit is a formula where you have an n in it that's describing the nth term, okay? So the n will, I shouldn't say describing, produce the nth term. Okay, and an infinite sequence is one that could continue on forever. So as I continue on with this one that we were just looking at, I could have put in a 5 and get the 5th term. I could have put in 100 and get the 100th term. I can jump to whatever term I want and calculate that term. Okay, all right, let's practice again. Example 2 here, write the first 5 terms of the sequence. So we're going to do the same thing. There's a little bit more to this formula. It is explicitly written, though, where I'm plugging in the n, which is the term that we're on. So I'm going to write it this way this time. A sub 1, we're discussing the first term. So it's -1 to the power of 1. It is now 1 squared, so that was me putting in the n there and the n there. And then on the bottom, it is n plus 1. So we're going to get 1 plus 1 and get 2. So this is going to be a -1 on top times a 1 over 2. So the first term is a -1/2. Okay, let's do the second one. We will have a -1 squared. We will have a 2 squared, that's me doing this and this, over 3. So this will be a positive 4 on top over 3. Let's keep going. Let's find a sub 3. -1 cubed, 3 squared over 4. Okay. We will get an a sub 3 of -9 over 4. Okay. They want the first 5. I'm running out of room here. So a sub 4, the fourth term is, this will be a positive 1 times 16 over 5. so 16/5. A sub 5, well, negative 1 to the power of 5 will be a negative. So that's a negative 1 times 25/6. We will get negative 25/6. So my first 5 terms are negative 1/2, 4/3, negative 9/4, 16/5, negative 25/6. And I certainly could keep this going, but I'm going to stop. Okay. All right. This next one, it's piecewise. So they're giving us 2 different situations. There is a line here, but it's just separating. It's not division. It is just separating what we're looking at. So if the n, so the term that we're on, that number, if it's divisible by 3, we're going to do an n squared. If it's not divisible by 3, we're going to do n squared. If it is divisible by 3, then we're going to do an n divided by 3. Okay? So when we're doing a sub 1, well, that 1 is not divisible by 3, so we're going to do 1 squared and get 1. A sub 2, it's not divisible by 3, so it's 2 squared, and we're going to get a 4. A sub 3, it is divisible by 3, so we're going to do the bottom, which is 3/3, and we get a 1. A sub 4, it's not divisible by 3, so 4 squared, and we get 16. A sub 5, not divisible by 3, so 5 squared, and we get 25. A sub 6, it is divisible by 3, and we're going to do 6 divided by 3 and get a 2. So my first 6 terms are 1, 4, 1, 16, 25, 2, Could I continue? Absolutely. So, you know, this is your a sub 1, your a sub 2, your a sub 3. We certainly could keep going. All right, but there's the first 6. All right, moving on. Next one, writing an explicit formula for the nth term. So here we have a sequence, and our job is to write the equation that produces it. Now, students often get thrown by the negative, especially when it's like part A here, where the negative is oscillating. So the first term is negative, the second one is not. The third term is negative. The fourth one is not. The fifth term is negative. The next one is not. So here's how we're going to combat that. We are going to say, for this case, a sub n is equal to -1. And if we raise it to a power, we will get it to oscillate between the term being negative and the term being positive. So I'm going to say to the n. Sometimes we might have to say n plus 1, depending upon how we're going to start. But for my first term, it's negative, so I do want it to be negative. So n will be, it'll just be an n for the exponent. Okay? Now that I got the oscillating negative positive business, now let's talk about how are we going to get the top to be 2, bottom to be 11. And now if you look, the top is 2, then the top is 3, then the top is 4, top is 5, top is 6. It does go in order. So I want to just say n, but this is the first term and I need it to be a 2. So how about I do n plus 1? Now, will that give me a -2? Got the negative, check. First term gives me a 2. If I'm on the second term, will that give me a 3? Yes. Third term, will that give me a 4? Yes. Okay, so I like that part. Now let's talk about the denominator. The denominator needs to be 11, and then 13, and then 15. So, let's see. Little trick to the trade. If this gap is consistent, and it is, we're going to have that gap is 2. So I'm going to say 2n. Okay? There's a trick. It will typically nearly always work unless there's something else going on also. So, but if this is just the first term and I plug in a 1, that's going to give me a denominator of a 2, not an 11. I would have to add 9 to it to make it work. Does that work for the third term? 2 times 3 is 6 plus 9. Does that give me 15? It does. Does it work for the fourth term? I would get an 8 plus 9. That's 17. It looks like it's working. Oops. So I like that for my equation for the second one. Okay, for part A. Part B. It's negative the entire time, and there's a 2 on the top the entire time. There's a negative, and there's a 2 for every single one of the terms. If that's the case, then I can just put a negative 2. Now let's talk about the denominator. Here I get a 25, and then I get 125, and then I get 625. I can't just go, oh, that's a common difference, because it's not. But it does multiply by 5 each time. So the first one is a 5 squared. The second one is a 5 cubed. The next one is a 5 to the 4th. So it's in the power that's changing here. So is it going to be an n? Well, that would be a 5 for the first term, not a 5 squared. Let's add 1 to it. Now, if I'm on the first term, this would become a 5 squared in the denominator. What if I'm on the second term? If I'm on the second term, it becomes a 5 cubed. Works. What if I'm on the third term? This becomes a 5 to the 4th. That works. I like it. We found our pattern. This is the equation for the second sequence. All right, let's go to the third. Ooh, this one looks very friendly. E is a number, right? I should put a sub n. A sub n is equal to e to the first term is a 4, the next term is a 5, have an exponent of 5. You know, that's a consistent increase each time. So how about I do n plus 3. Would that give me a 4 for the first one? Yes. A 5 for the second one? Yes. A 6 for the third one? Yes. And I'm done. That's it. Okay. Now, we were working with explicit formulas. Those were explicit formulas because the n that you plug in is telling you the term that you're on. There is also recursive formulas, which uses previous terms. Maybe 1, maybe 2, but previous terms. 1, 2, doesn't matter how many. Okay? Like, look at example 5 with me. They're telling us the first term is 9. Okay? So if we were making a list, the first one is 9. Now, for everyone after that, they want this right here, a sub n minus 1. That is the previous term. Because if you're on, say, the second term, this would really be a sub 2 minus 1. So if we're trying to solve for the second one, we do 3 times the first one, then minus 20. So you have to know this when they do n minus 1 as a subscript, that is the previous a sub n. Okay? So that means I'll just do a sub 2 right underneath this. Okay? A sub 2 is equal to 3 a sub 1 minus 20. Well, we know a sub 1 is 9. So 3 times 9. Okay, so now we have 27 minus 20, which would give us a 7. So the first term was a 9. Second one is a 7. Let's do a sub 3 now. If I'm doing a sub 3, It's 3 times the previous, so a sub 2, which is 7, and then minus 20. So that's 21 minus 20, and we get a 1. A sub 4, when n is a 4, this will be 3. This would become a 3. A sub 3, which we know is 1. So 3 times 1 minus 20. So 3 minus 20, a negative 17. A sub 5, three times a sub 4, which is a negative 17, minus 20. Let's see. 51, negative 51 minus 20 is a negative 71. And this could continue on. So what makes it recursive? We're using the previous numbers. Okay, so a previous term. All right, let's practice another recursive. This next recursive, example 6 here, they give us the first two. Now let's talk notation here. When we've got this one and we have this one, okay? So when we're on the third, let's say a sub 3, this is going to be 3 times a sub 2 plus 4 times a sub 3 minus 2, 1. So you're using the previous term and then even 2 previous terms, right? So we would do, for the first 6 terms, first term is a 1, second term is a 2. Third term is going to be 3, I'm going to go right underneath here, 3 times the previous term plus 4 times the one before that. So 6 and 4. So this one will be a 10. Okay? Now, if I'm on the fourth term, it's 3 times the previous term plus 4 times the one before that. So we will have 30 plus 8. Next, the fifth term, 3 times a sub 4, which is 38, plus 4 times a sub 3, 10. Let's see, 30, 90, and 24, 4, 114, and 40. 154. Let's go one more time because they want the first 6. The sixth term is going to be 3 times 154 plus 4 times 38. 154 times 3 is 462. 4 times 38 is 120 and 32, 152. So we get 614 here. There's the first 6. And it's recursive because we used previous terms. Okay. All right. What does factorial mean? Factorial means you're going to take that integer and you're going to multiply it by every integer smaller than it on down to 1. Okay? So, a couple of basic ones. 0 factorial, by definition, 0 factorial is 1. Okay? So that's a given. 1 factorial is 1. All other factorials are that number times every number smaller than it. So, I'll give you an example. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay? Some people go, oh, well, 6 factorial is equal to 6 times 5 factorial. Well, sure, because 5 factorial is 5, 4, 3, 2, 1. Right? I would rather us remember that it is that number, like here, 8. I'm not going to put 7 factorial. I could, but I'm not going to. I'm going to say 7, 6, 5, 4, 3, 2, 1, on down to 1, multiply together. Okay? So that's what this is. So if it was 8 factorial, 8, 7, 6, all the way down to 1. All right. Write the first 5 terms of this sequence. So now that we know what a factorial is, we can start working with stuff that looks like that when there's a factorial on it. So first 5 in this sequence. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Okay? So when we're looking with the first term, 1 is going to go in here. So top number is 5. Bottom number is 3 factorial. Okay? So that is really 5 over 3 times 2 times 1. So it's 5 over 6 for the first term. When we're doing the second, 5 times 2 on top is a 10. On the bottom, we're going to put a 2 in here, so we'll get a 4 factorial. So it's really 10 over 4, 3, 2, 1. Yes, 10 is 2 times 5, so we could do a little bit of simplifying, right? Divide that by 2, divide that by 2. So it's 5 over 12 when all is said and done. Okay. A sub 3, top number will be a 15. Bottom number will be a 5 factorial. So 15 is on top, 5, 4, 3, 2, 1 on the bottom. Well, 5 times 3 is 15, so this simplifies to 1 over 8. Okay. A sub 4, we'd get a 20 on the top, and we'd get a 6 factorial on the bottom. 6, 5, 4, 3, 2, 1. Well, 6 times 5, not 6 times 5, excuse me. 5 times 4 is 20, so this simplifies. And we have 1 over 6 times 6, so 36 down there. All right, one more since they want the first 5. 5 times 5 is 25. On top and on the bottom, 7 factorial. So 25 over 7, 6, 5, 4, 3, 2, 1. Well, both 5 and 25 are divisible by 5, so we'll simplify that. This is as good as it's going to get. So we have a 5 on top, and the bottom is 7 times 6 times 4, 3, 2, and 1, and that is 1008. And could I keep going? Absolutely. So this is a sequence. And this is a explicit formula because we didn't need the previous term. We just had an n. That's it for this section. The next section is going to be on arithmetic, and the one after that, geometric, and then the one after that is going to be on series, which is adding up sequences.